integration by partial fractions. So we've done partial fractions, so we can find in the book, you can just review that. Start with example 31. This is page 116. Alright, so page 116. Start at example 31. So it says, determine the integral of this. X over x plus 1 times x plus 2. And they started this way just to set it up. So say, let's just change this into partial fractions. So you remember how partial fractions go? You take this, x over x plus 1, x plus 2, and you want to break it up into a over, that's linear, x plus 1, and then plus b over x plus 2. And remember how the shortcut way to do this?
Yes, sir.
You take this value, 0 in the denominator, right? And then you plug it into this. So what is the number? So it's going to be x equal to -1. So a, so let's make a little note. This -1 here is what we're going to give me a. So a is going to be equal to, if I plug -1 to this, not this bit because -1 makes this, I have -1 in the numerator over -1 plus 2, which is positive 1. So my a is equal to -1. And then for b, what we're going to plug in? X is
Sir, do that again, please.
-2.
Sir, please do that.
I see how this one out. Same thing. Try catching this up and go back over there. I zero out the denominator. So what number makes the denominator 0? It is -2. What makes this denominator 0? Was -1. I'm going to plug it into the relevant part. So I'm blotting out this part now. So I'm plugging into this and this. So it's going to have -2 in the numerator divided by -2 plus 1 is -1. What's -2 divided by -1? Positive 2. So therefore my A is -1, my B is -2.
Yes,
I would say we only work this when what? When is the single linear fraction. We didn't do it with the square one. Remember, we actually go through the process. So this is going to be the same as now. We'll say integral, let's share out, -1 over x plus 1 plus 2 over x plus 2 dx. So what we can do here is take the integral of these respective sums. So we can do them individually. So this becomes the integral, right, of -1 over x plus 1 dx plus the integral of 2 over x plus 2 dx. Now remember, anytime we have a case where the numerator can be expressed as the derivative of the denominator, it becomes a natural log. So, what's the derivative of this? Is just 1. So, but I have a -1 here. So, which means if I put the negative outside, now my numerator is the exact derivative of the denominator. So, this just becomes natural log of the absolute value of x plus 1, and this negative comes down. So you have to remember this rule. Remember about the board. Let me highlight the rule that we're using. The rule that the integration rule we're using is this. The integral of f prime of x over f of x dx is always equal to natural log actual value of plus c. As long as we can identify the derivative of the denominator function in the numerator, that's all we get. Alright? Remember, the derivative of natural log is 1 over the thing. Or the derivative over the side. So, in this one, what we do now? The derivative of this would be 1. So how do I get 1 up here? This 2 could pull out. I Right here, and look at that. 2 times 1 is still equal to 2, right? You see? 2 that was here is the same as 2 times 1 over x plus 2. So I could move this 2 outside here, just like I move the negative sign out, and then the 1, because this time is giving back the same thing. Kind of multiply numerators with a fraction, that's all. So now the numerator is the exact derivative of the denominator. So this becomes natural log of x plus 2, and this 2 comes down here. And then complete the integral. So the integral of this is that, a partial fraction.